Good afternoon, everyone. Thanks for joining today's webinar, Discovering the User Interface and Functionality of Alpha Battery Backup. My name is Connor, and I'll be your moderator. Before we get going, just running through a few quick housekeeping items. All your phone lines are muted, so if you have any questions, feel free to use the chat feature within the GoToWebinar toolbar. Presentation will last about 40 minutes or so, which will give us some time for questions. By attending today's webinar, you are eligible to earn IMSA or TARP points through IMSA. For those who provided your IMSA number during the registration process, Western Systems will go ahead and handle the submission to IMSA for you. A copy of today's slides are available. You can download those within the handout icon in the GoToWebinar toolbar. And lastly, today's webinar will be available on demand. You will get an email tomorrow with a link to do so. And with the housekeeping out of the way, I'm very excited to introduce today's presenters, John Nagel, Territory Manager at Western Systems, and Jack Tolbert from Alpha. John, I'll turn it over to you.
All right, very cool. Thank you, Connor. Appreciate the intro, and thanks for joining us, everyone. Hope everyone is adjusting to the new normal and enjoying all these webinars, not getting too much webinar fatigue. That's kind of the thing nowadays, but I don't think that's the case with us. We've got a lot of positive feedback from this series. That's kind of where this presentation came from, feedback from the presentation we did a few weeks back by Kai Antrim. So that's kind of where this one came from. Like Connor mentioned, my name is John Nagel. I'm the Territory Manager for Central and Southern California. Recently, relatively new to the team. Very excited to be joining the Western Systems squad, and looking forward to finally, at some point getting out to meet all of you. So I don't know if we'll be able to shake hands at that point, but whatever we're doing, looking forward to getting out of the office and meeting everyone. So like I mentioned, we got a lot of feedback from our first Alpha presentation, a lot of positive feedback from you guys, so I appreciate that. But there were just some topics that we wanted to go a little bit deeper into. Kai touched on some of the technology of the solution. We're going to talk a bit more about maybe best practices, lessons learned from other customer deployments out there in the field. So with that, I will kick it off. Oh, I'm sorry. Sorry, Jack. We've also got Jack Tolbert on the line. So I'm gonna do a few slides, just kind of overlapping these best practices and lessons learned. Then I'll throw it over to Jack Tolbert, who's going to walk us all through Alpha's RBMS, their monitoring tool for their battery solution. So that'll be a good hands-on demo that Jack's going to provide. So a little update on us. We are open for business. We were deemed essential for production. So production continues. I know others haven't been as lucky. International production, coming into the U.S. seems to be a bit more challenging. So, our team is hard at work up in Washington, so we're really appreciative of them. And of course, they're acknowledging all the social distancing. So right there, that's not a live photo, but that's a shot of our warehouse and a shot of our external. Just a brief history. We've got a big history with custom cabinets, providing them into the market. That's kind of the cornerstone of Western Systems, and from there we've grown significantly, leaps and bounds with both the personnel, but also in the solutions that we provide. So we went from being a hardware provider to a true solutions provider, touching everything in the intersection, everything in the cabinet, from detection to signal heads to mast arms to the whole nine. We essentially touch the intersection, so we can assist with that. We're located in California, Oregon, Washington, Idaho, and Montana. And we've got a team of local technicians that can help support both pre-sales and post-sales. So that can assist with the design of many systems, implementation, and then the post-sales support as well. So as I mentioned, we've grown obviously with people, personnel, but we've also grown with product lines that we've supported, or product lines that we wanted to provide. And as we've come to learn, we've gotten much more discerning on some of the product lines that we choose. And Alpha was definitely one of the ones that we were very picky about, that we wanted to partner with them. Between the runtime of their batteries, the functionality of their UPS, their strong warranty, addition of remote monitoring, there really wasn't a better solution for ITS applications. So we've got a good history with them. The Pacific Northwest, we've been working with them for about 10 years. And just last year, we picked them up in Southern California. So very excited to get out there, educate and promote the Alpha brand in Southern California. Again, we're unique in the sense that we've got a team of technicians that are local that can help with the design and everything along the way. So jumping into kind of a topic that was touched on the last presentation that we wanted to go a little bit further into was intersection prioritization. You know, in a world where, you know, we've got limited resources, you know, take toilet paper, for example, right now. You know, we wouldn't be in the toilet paper craze if we had unlimited amount of toilet paper. Same idea with, you know, resources for supplying battery backups for intersections. Would we like to back up every intersection, every signalized intersection in the city? Of course. But that's going to be a challenge with funding sources. So, you know, whether it comes down to, you know, you've got a determination that you're going to back up 50% of the intersections, you know, how do you prioritize what 50%, you know, which ones you do, which ones you back up? Or your plan is to roll out 100% backup of your signalized intersections. How do you plan that rollout? How do you determine which ones go first? So we just wanted to touch on some of this. Here's a list of a few of them. Now, obviously, you guys have your data on a lot of intersections, engineering data on which ones were going to be the higher priority, but wanted to give a snapshot of what some things to keep in mind are as we're doing that. So one piece is you know, known intersections with ongoing power disturbances. You know, we're able to control power once it goes into the cabinet through a UPS. However, power outside the cabinet, that's out of our control. We had a customer who had a signalized intersection that was located very close to a large manufacturing facility, and roughly every you know, consistently every day at the same time, that intersection was going into flash. So the city couldn't really determine what was causing it to do that until they realized that corresponded with shift change. So what was happening was, as that shift change was occurring, there was a huge draw of power into that facility, which caused a sag of power going into the cabinet, which caused the CMU, the MMU, and the intersection to go to throw the intersection into flash. So what they did, they determined they needed to address it, obviously, and they implemented an Alpha UPS into that cabinet, and it was kind of a set it and forget it type of scenario. But once it was in there, that issue hadn't been addressed, and the UPS was able to condition the power going into that controller to all the equipment in there to a more palatable voltage, so it didn't have to go into flash. So that's one piece there. Obviously, our intersections with high volume of accidents and high volume of just in general high volume. You know, these are intersections that, you know, essentially high leverage. You know, you've got a lot of cars being affected, a lot of vehicles being affected by these intersections. So those are some you might want to focus on. Controller equipment failure. You know, this essentially might just be a symptom of you know, a power disturbance. You know, this ties into essentially an unknown intersection with ongoing power disturbances. We've got our evacuation routes, our emergency routes. So main routes versus alternate routes, major routes versus secondary routes. You know, those are how we can kind of prioritize which get the backup power. And then also interesting, you know, right now it's not a mandate, but there is potential that the MUTCD could mandate battery backups on all railroad crossings. So again, that's just something to keep in mind as we venture forward. Other things to consider as we're prioritizing these intersections. You know, I want to look at ramp intersections, how this is going to affect freeways. You know, does that ramp back up onto a freeway and cause downstream gating? Do we have hidden or obscured intersections around corners or hills, so the potential of higher accidents? You got main corridors that can back up traffic for miles, intersections that really significantly affect the traffic flow, intersections that have a high red running intersections also might be something you want to focus on. And then, of course, if you've got the ability to design it into the implementation of let's say a net new signalized intersection, building in a battery backup into it is nice to do from the ground up. Now, this is just a little review of what we went over on our last presentation. Kai touched on all this, and I just wanted to address it briefly. We talked about just in general the importance of backup battery, the different topographies, the line interactive, the double buck, double boost topographies, different compositions of the batteries, their differences, preventative maintenance on the batteries, and then also more traditional enclosures. So if any of these topics, if anyone missed out on this conversation, please reach out to us. We'd be happy to go over with you again, or the video is on online for you to view as well on our website. But then also, a quick review of what we're talking about here in terms of the wiring diagram. We've got our inverter here on the right, our transfer switches on the bottom, generator transfer switch here, our 4 batteries, and our heater mat. Something that wasn't addressed on the last call, which we've gotten questions about, is this little LRI beacon. I've gotten some questions on what that does, and essentially, if your intersection doesn't have comms, it's hard to tell if your intersection's gone into battery backup because you don't have that communication back to the TMC. What this little LRI beacon enables is a visual. I mean, that little beacon will be put on the outside of a cabinet so that technicians can tell visually from far that intersection's gone into battery backup. So that's just wanted to touch on that. That's something that we didn't quite mention last time around. So how do we design and protect the system? I mean, if we're going from a net new solution, a net new build, we want to look at the various elements that are a part of that install. We want to design it once, so that way it's it's close to that set it and forget it type of mentality as we can get. So what we want to look into is the load of the cabinet and everything in there, and also the runtime that's required. So the load, we're going to add up all the equipment, all the technology that's within there. That'll help us calculate what type of inverter we need, what all the battery type, the battery capacity, and then we'll also want to work with you to determine what type of runtime you guys are going to require. Nationally, average runtime is around 2 hours. However, we want to be prepared for something significantly longer than that, and we've got a nice little equation that can help out with that. So from that, we can prescribe the UPS, the battery capacity, essentially the type of the battery, and how many batteries would be good for the system. And we've got a nice little tool that we'd be happy to share with you. It's a calculator that takes these elements, plugs them in, and then spits out essentially a runtime. So for example, down here, I've got a 1100 watt inverter running 4 80 amp hour batteries handling a 400 watt load. Will give us an estimated 7.5 hours of runtime. Now, again, it's an estimate. That's more of a metric that's being used for comparison than a hard and true number in the real world. That's based on a 77 degrees Fahrenheit in a vacuum, all else being equal. That's the number that we're going to work with. But what we can use that is, again, as a metric. Do we need to beef that up to an 8 battery system? Do we need the capacity of the batteries to be 100 amp hours, 112 amp hours, which then affects the size of the batteries. And, then we get into our enclosure, how much space is this going to take up? So a lot of different elements that go up in terms of designing, those type of elements. And then touched on right there, the different types of cabinets that can be prescribed for the design. So on the image here, I've got our custom cabinet. This is called the P+. It's a NEMA style cabinet with custom pocket here on the right, nice and clean, and a custom area right here with a inverter and transfer switches mounted vertically. This is all within the cabinet. And then if we shut the door and turn it sideways, this is a look of what we're looking at here. And there you've got access to your batteries. So the batteries are essentially within the cabinet still, but they are separate for temperature concerns. So it's kind of nice, very clean. It doesn't stick out significantly forward, kind of like a piggyback enclosure would. But this is unique to Western Systems and something that is a big attraction for us. So we touched on intersections, but what are some applications for backup batteries outside of intersections, but still in the ITS world? So we actually had a customer that had an interesting application that employs something called the micro BBS, the micro backup battery system. Customer is up in Washington County, Oregon, And their situation up there kind of different from us in Southern California, but they've got a lot of applications where they need to allow their vehicles, allow the drivers to know that they need to carry chains or traction tires. So this is their setup prior to doing any type of ITS equipment, any type of technological signage to alert their drivers that they needed to carry chains. So what their standard procedure was, the crew had to drive out to 9 different locations across the county and climb up on a ladder, undo a padlock, and basically turn down a hinge and a flap. That flap would allow you to see this carry chains or traction tires. All of that, it's a 4-hour round trip just to turn them on, just to open them up, and then when you've got to close them down, it's another 4-hour round trip. You've got a potential danger of your crew driving out in inclement weather, and you've got them going up on a ladder. So potential danger there. So what they did to address it, at least the first go around, was to implement these flashing beacons. So instead of having that flap that they'd have to climb up and flap down, they've got this basically a switch that they'd go out and hit. So when that was flashing, their drivers would need to have traction tires or chains would be required. Problem here is, we're running the same issue with their crews needed to go out on site. It still took around 4 hours to do their round trips, to turn them on and to turn them off. And they were getting calls that their lights were going out. So these things that we weren't able to do from a remote aspect. So they kind of recognized they needed to address this with some kind of ITS solution. So they worked with us, and what we did with them, we developed this micro BBS. So this is a 350W inverter, FXM 350, designed for a much smaller load, a much smaller form factor, but very specific to an ITS application. What we installed here is obviously our inverter on top. Batteries went onto this shelf here. They've got a cellular modem on the bottom because they connected a bullet camera as well, so they can monitor the area and make that determination if the chains would be required. They could make the determination themselves instead of going to weather.com to do it. So once we built that all together, they mounted it on a pole. You can see the bullet camera on top there. And now they went from a 4-hour turnaround time of getting all their signs addressed to the new setup to now something that takes them less than 5 minutes to access. So they're able to make the determination remotely with that camera that you can see right there. So they can look at each location to determine if they need to turn those lights on. And they've got the battery backup solution in there, so they can discover if those batteries, if the intersection's gone dark or if that street's gone dark and the batteries are now on. So again, just a huge benefit and an example of kind of a unique ITS application for battery backup. And I'm going to throw it over to Jack in a sec, but essentially this is another element that went into that application, an RBMS, the remote battery monitoring system, where you're able to see the health, the voltage, and the temperature of a lot of your batteries that are out there deployed in the field. You can set up alarms. If those batteries get to a certain threshold, you can start planning your purchase of your next batteries, and overall just a really strong tool for watching the health of your battery. So I am now going to hand it over to Jack. Hopefully we can get this right. And Jack is going to walk us through a little bit of the software.
Yeah, let's see if I can get do you see my screen?
Yep. Looking at RBMS plus.
You got it? Okay.
Looking at it.
Okay, yeah, so basically this is the RBMS to pick up where you left off. It stands for Remote Battery Monitoring System, and what this enables you to do is to monitor your batteries remotely, just as the name suggests. And the value of this, it allows you to do it from your laptop. It's going to do 95% of your maintenance sitting from your desk. You don't no longer have to go out there to the field with a battery probe and go out there and pry, poke, and everything else, scrape your knuckles. This does all that for you, but more importantly, it sends that information back to you. It gives you the information so you don't have to go out there and get the information. So basically a simple wiring, this is the wiring diagram. It's powered over the batteries that are in the cabinet, which we recommend that you power it over 48 volts, but it needs to be at least 24 volts. So you would see you got your positive and then your negative, and this sits back. And then each battery would get its own module. And each module has a little LED, you can't really see it here, but right in the front. So when you install these, you want to make sure that you have the LED facing the door. So when you open the door, you can see if that little LED is blinking or not. So that's basically the wiring diagram for it. There's not much to it, pretty easy. And then they're daisy chained back to the RBMS itself. This is just a front and back look of each one of them. So after you log into it, so let me log in here. This is the new software, which actually was just released yesterday. So you guys are actually the first ones to see it. Bear with me, be patient. I just got it as well yesterday, so I've been kind of playing around with it. It's a little different, a little new, but it's a lot simpler and easier to use. Just like you go into your dashboard here, we try to simplify it by making it as color-coded as easy, and then everything's like right here. All the information that you would need is right here on your dashboard. There's really no need to dwell down into it, and except for in the initial setup, because there's some alarms you want to enable. But this kind of shows you right now, if you look at it, I've got an alarm. This admittance value has dropped below a threshold, and I'll show you how to set those up in a second. But so instantly you have a visual of what's going on. You know one of the 4 batteries has got an issue. And there's also, you will set it up to where you would get an email notification that this has happened. So once that alarm is triggered, you would get an email saying, hey, you know, battery number 1 has got an issue. And then you would be able to remote into it and get a better idea of what's going on with it. So here's how this will look. And then, so the first things you would do for this when you get it, as you notice, it's got your overall string, 54 volts. Each battery has its own voltage, its admittance, and its temperature. So what you would do first of all is you would set up the starting point of your admittance. Your admittance is basically the health of your battery. Each battery, when it's brand new, it has an admittance value, and that's the starting point. Everything below that, it shows you where that battery is deteriorating, and over the life of it, as it gets older, this number is going to get lower. Like I said, this is a demo. I'm actually piped into Burnaby, Canada. So this one's kind of a mess. They've been just kind of playing around with it, putting different batteries on it. So your battery variances wouldn't be like this. It should be much closer. Like here, you got 1074, 1026, and then you got this one here at 864. So this obviously should be a much older battery than these two here. But this is basically just for a demo purpose. So when you're first going to set it up, as you get it, you log into it. You're going to go set up what the initial admittance value is. So what you would do is you would take the 4 admittance value of each one of these and you would average it out. And then you would just click over here in this open field and scroll down to battery admittance. And this is where that number would be. So let's just say I just put 1100 in there just so you would see that there was an alarm already set, but you would take that average number, plug it in there, and enable these alarms. Now, these alarms are also not quite correct because it's a demo, but this typically would be at -20, and this one would be at -40. Because anytime your battery starts to get past that -40, that means it's aged, and it's about time you need to start looking to replace it. When it hits the -50 mark, it's time to replace it. You need to go out and start funding, get your funding ready to replace it because it's on its last leg, basically. So once you've set those alarms, you go ahead and hit update alarms, and then you come back in here, and then you would start your deltas. And that's how this number came up. So this number here, 864, is 21% less of that 1100. So, and each one as they deteriorate would go. Now, this one obviously stands out. This could be a potential problem, or maybe the system is 5-6 years old and all of them have these. Well, that just means your overall system's just aging, and that's just a good time to start looking, to get ready to replace them. One other thing that we did is kind of cool is you want to give it a name. So in order to do that, you would just click on this field, and up here you would type it. And as far as our best practice, one of the things that we would do is so you would easily recognize what these batteries are, so you don't have to have a separate data sheet to say, hey, at this intersection, I have these type of batteries and they were installed here. Let's put that information here. So let's say these are XTV 240 batteries. The original admittance value was 1100. You would put that in when you first get these. We installed it in May of 2016, and this is battery 1. So now you can just take that information and just copy it and then go down to each battery, click on this one, paste it in there, go to the next one, and so on. So now when you would look into it, obviously I can't change it because this is not my system to play with, but when you looked into it, that information would be there and you automatically know what it is. You say, oh yeah, we installed these batteries back in 2016, they're 4 years old. Okay, now they're at the time that we need to start looking at them. So that's the whole point behind setting that up. This is another just visual, so you don't have to keep a separate log for what it is. And then at that same time, let's give it a name. You could say this is Fifth and Main, and if you did asset management or something, you could give it its number if you had a numerical number or something that you used here. So when you logged in, all that information was right there in front of you. There's, like I said, there's really no need to dwell down into this. So, I mean, it's kind of new. Like I said, it's brand new. It was just released yesterday. I've just been playing around with it a little bit. I'm still learning some of it, but it's really a lot simpler than what the other version is. And I don't know who's on the call has used it and has not used it, but you know, it is backwards compatible. There's a couple steps that you need to make to upgrade your existing ones. And we have a whole, they just released it this morning, the whole little sheet that you go step by step, and it'll basically do everything that I just did. It'll show you how to do it in steps, and what we recommend is a little best practice sheet that we'll make sure that we have available for you guys. And I haven't sent it to Connor yet, but I'll make sure that happens after this meeting. So once again, if you want to download the presentation at the same time, we can also give you this sheet to download as well. For the most part, that's pretty much it for me on this. I mean, it's just kind of cool that we simplified it and it's brand new. Now, the one thing I will suggest, it is, like I said before, if you have comms, this is a great thing, but it also works if you don't have comm. And to give you a quick example of that, so Peoria, Arizona, they don't have comm, but they're getting comm to the intersection. So when they buy a system, they go ahead and buy with RBMS. And the guy called me up and said, hey, Jack, I was out there doing my PM. He goes out there, he flips on inverter, and he said 20 minutes later, his cabinets went to flash because it reached that 40%. And I said, well, that doesn't make sense. His batteries are only 1.5 years old. And I said, okay, well, let him charge up overnight and let's do it again. So the great thing is he was able to come up here, plug his laptop into it. And I said, let's take a screenshot. So everything that we need, if you're going to file a claim for a battery claim, they're going to ask you, I need to know what the admittance is, what the voltage is, what the temperature is. And all that is right here. So you even have, you know, you got a time stamp. Everything, we had a voltage, everything was running at 13.5, right around here. And I said, okay, take a screenshot, now flip it onto inverter. So he did, and about 20 something minutes later, it went into flash. And what we saw was battery number 3 dropped all the way down to 9.1 volts really fast. Well, that took the overall string down to 40 volts, which put the intersection into flash. I said, perfect, now take another screenshot of that. And by doing so, we were able to call tech support. We had all the information that they needed to replace that battery. We knew how old it was because it had the date right there. We had the admittance, the voltage, the temperature, everything that they needed, and we put another battery on the truck the next day. You know, that's the one disadvantage about batteries is freight. So when you call and you want to file a claim against a bad battery, they're going to ask for all this information because they're not just going to say, hey, I got a bad battery. Oh, okay, we'll send you some new batteries. It just doesn't work that way. So it's a very valuable tool, even if you don't have comm. But like I said, you could even do all that battery testing sitting right here. So that's another huge asset. So the other part is, like, right now, if you were looking at this battery and you're wondering, okay, I need to send my technician out there to take a look at this battery, it's got this little LED sensor right here that you would just click this and enable it, And so when your technician opened up the cabinet door, that little LED that was on the front of that module would be flashing. So he automatically knew it'd be flashing red and green. So he knew at that point, that's the one he needs to be looking at. So he's not out there trying to, like, again, with a battery tester trying to poke and prod each one of those. He automatically knows which one he needs to look at. Maybe it's a bad battery, maybe it's got a bad connection, or maybe it is swelling or leaking or something. So at least right there, he knows which one he needs to focus on instead of trying to figure it out. So it is a huge asset. It makes doing your battery maintenance a lot easier. All that information is sent to you, email, anytime you have a problem. So the idea of an RBMS is to let you know that you have a problem before you have an outage. And all of a sudden you say, well, what good is this UPS because I've got a dark intersection. We got bad batteries. You're going to know you have bad batteries well before you have a potential outage. So that's the value of this. That's pretty much it for me on this. We can definitely make sure you guys get all the information you need to upgrade to the newer software. With that, if you have any questions, let me know.
All right, thanks, Jack. We'll get going on the Q&A here. If you have any questions, feel free to type them in the chat feature there within the GoToWebinar toolbar. And we did have a couple that came in during the presentation, Jack, so we'll just dive into those. And the first one is, you had mentioned admittance earlier. What exactly does that mean?
Yeah, right. Good question. So admittance, each battery, when it's released, has an admittance value. The bigger the battery, the higher the admittance value is. And really what that is the ease that the current flows through the plates in a battery. So as the battery ages, that number goes down because of the resistance from the corrosion. So that's how we determine what the heartbeat of a battery is by the admittance. Now, again, it'll let you know of where it is in its life cycle. The higher it is, and that works 98% of the time. You can always have a flaw where a cracked plate or something, but for the most part, the heartbeat of it is the admittance value. And it's also known as a Siemens value. That's why you see the S after that number.
Great. One more for you here. Someone says, we currently have AlphaGuard deployed on our batteries. Does this replace it, or can it be used simultaneously?
Correct. So it replaces it. The AlphaGuard was just a battery balancer. Didn't give you any information. All it did was balance your batteries. This one balances the batteries, but then it also gives you all this information. So it's smart, where the AlphaGuard was basically dumb. So no, you would not use them both. You would use one or the other. And the ideal time to put an RBMS on a system is when you're replacing your batteries, because again, we want that initial beginning Siemens value. We want that starting point. So you really wouldn't want to go put an RBMS out there on batteries that have been out in the field for 3 years, because you don't really know where they started off at. You really want to put them with new batteries. It's easier for budgeting and everything else. Now we have a true starting point, and we can watch as those batteries that deteriorate over time, we can see where they're at by having that true number.
Great. That's all the questions we got. So thank you, Jack. Thank you, John. And thank you, everyone, for attending today's webinar. Have a great afternoon.
Cool. Thank you.
Thanks, everyone.